Throughout my career, I had the opportunity to witness developers and leaders get frustrated because of security related processes that were designed in a non scalable manner. I wanted to break this cycle by bringing practical examples on how platform engineering can play a key role on bringing security in your development lifecycle and helping you release hardened applications. Hi, my name is Martin Illuminati, and I'm a director of platform engineering. I'm going to be walking you through on how platform engineering can provide all the necessary means to apply security at scale while maintaining a positive developer experience throughout the development lifecycle. We're going to be going through three main phases in the SDLC. We're going to be going through the code, build and deploy, as well as the monitor and operate phase. Even though I'll be going through tools and configurations, what I'd like you to take out of this presentation is the potential positive impact that addition or changes in the existing process that you might have can have within the overall security posture of your company. I will be adding links to the code as well as tools that I will be mentioning in the description of the video. Additionally, for these changes to have a broader impact, you may want to understand what is the current threat landscape that drive your risk areas within your infrastructure and application. In our case, we're going to be looking into secure cloud configuration, container security, secure development, and dependency management, linked into Python, Docker, Terraform, and AWS. Something to keep in mind while we go through is that the cost of fixing a defect within each of the LCSD phases increases. So the earlier it gets detected, the bigger the savings are within remediation. And with that said, we're going to start with the code phase. And for that, we're going to be answering the question, how can platform engineering help the developers detect and correct vulnerabilities when coding with a positive developer experience? And that has to go both for the infrastructure and application related code. The first approach that we can have is to leverage IDs that developers use, being VS Code the most used. Using extensions is a simple and effective way to highlight potential mistakes and provide real-time feedback on how to get it corrected. And that is exactly what we want. We want to give developers a quick feedback loop that they can action it quickly and without too much interruption. And for that, we're going to be jumping on a quick demo around VS Code extensions. So we want to enable developers with a curated list of extensions that can help them find vulnerabilities in real time, so where they're developing. One way to accomplish this is to create an extensions.json file for VS Code with the list of recommended extensions that they might be able to use. If these extensions are not installed, what will happen is when they open the development environment, a pop-up will appear that says, do you want to install the recommended extensions for this repo? We should say install, and we're going to accept all the recommended extensions, and that will start the process of installing them. You might already have a process for creating new projects, like Backstage. So this might just be one more file that Backstage would be creating within your new repository. In my example that I have, what I'm going to be doing, I'm just going to be creating a new Terraform file. Let's just name it PlatformCon. Yes. And I'm just going to paste a piece of code that I have, which is quite vulnerable, as you may see. But the idea is that in real time, you get the feedback of what are the vulnerabilities that might have been noticed within the code. So those are all highlighted. Also, which is something nice about this particular extension is I can I'll let you just classify them. But this will be something that you will adjust depending on the language that you're using for development. The other approach that we can take is to provide pre-commit hooks. Pre-commit hooks are scripts that are automatically executed before a commit is made. This allows for automated checks. So when a developer runs git commit, the pre-commit hooks are executed, and if they run successfully, the code is actually committed. What's important to highlight is that we want to only have pre-commit hooks that are highly performant. That means that they execute quickly, and this is to avoid degrading the developer experience. In our case, we're going to be using it for a few tasks, so for secret detection and for software composition analysis. So pre-commit hooks can be described through a file as well, which is the pre-commit config.yaml file. This also allows us to provide this file with all the configuration when a new repository is created. In our case, we have one hook that is dedicated for detecting secrets, another one for detecting or doing a dependency check, and a third one for doing linting on YAML and Python. The list of available hooks is quite extensive, really, but if there's no one that matches the needs that you have, you can also create your own hooks, which is pretty simple and pretty straightforward. Uh, in our case, what I'm gonna be doing, I have the Terraform file that I changed in the previous demo. I have an app that has been created, and I'm about to make a commit. The app itself has a config.yaml file, which has AWS secret and key right there in plain text. Note that the extension is just telling me, hey, you should not be doing this, but let's say that I will ignore this. I'll not take a look into the notification, so it's just commit it anyways. And I also have a requirements.txt file, which is just the Python dependency. So just gonna make a commit in here. So commit test commit hooks, and I'm gonna make a commit. So now all the pre-commit hooks are actually executing, and it's telling me, hey, uh, the pre-commit hook detect secrets actually failed. So I'm gonna open the log, and I'm going to go through this. The first one, which was the detect secrets executed, is telling me, hey, you have uh, AWS keys in there, so I'm not going to let you commit because of that. And the second hook, which is for dependency check, it scanned one package and found 5 vulnerabilities into it related with URL live, which is an outdated version. This one is the one that I should be using, so I'm gonna make those changes in here. And instead of having these, referencing it. Save this, show the changes. And what I can also do is just, instead of running it through VS Code, I can just run it locally. Terms of validation, everything passed. Everything should pass now as well. Perfect. Moving into the build and deploy phase, we're going to be answering the question, how can platform engineering help developers avoid vulnerabilities to be deployed into production? So the code is now committed, is pushed, is sitting in a repository. It would be natural to expect that a CI pipeline will be actually executed against that code, which is exactly what we're going to be leveraging. As a quick refresh, these are the risk areas that we identified earlier, and these are the controls that can be put in place. So we have just checking the infrastructure as code, scanning the containers, doing SAST, and software composition analysis. Now, leveraging a pipeline to make validations has the advantage that we can run tasks that might be a bit more resource intensive that we couldn't run before because of the potential degradation of the developer experience. In general, if you identified several points of analysis in terms of the risk that was identified earlier, you might want to analyze them all where possible within the build phase, as this is the last step before the new code gets actually deployed into production. In our case, we're going to be committing code, which is going to be getting to GitHub, which is what I'm using. and then a series of build steps are going to be executed, and a set of validations are going to be done. So like any CI, GitHub let us have the different CI steps defined as code, in this case under the GitHub Workflows folder, the main YAML file. Just going to be a quick walkthrough on this. We have the container scanning step that we were talking about that has Trivy to make the scan itself, infrastructure as code scanning done through CFN now, software composition analysis that we're going to be using Gripe, in SaaS that we're going to be doing with Bandit. Now, naturally, the deploy step will be dependent on the execution of all the other four different steps. Now, if we look into GitHub, this is the result of the last commit that we did. Logically, because we haven't scanned containers before in any of the other prior steps, we found that we have an issue. You open it up, and it's just telling us that we're running an outdated version of Alpine in this case, which is true. And we have 8 high-risk vulnerabilities. So going back here, have my Docker file, which is being analyzed, and it's telling us that yes, it's an old version of it. So if I'm gonna be looking into this, the 18, so this is gonna be the last version of it for Node. Perfect. Updated, no image. Just gonna make a quick commit. Changes. And have the action running. Perfect. So we have the test that actually passed, and we have all the steps that were successfully executed with a deploy step that ran and went through. So this demo covered the basics on running security validations within a CI pipeline. This topic was covered much more in depth in Abiram's talk from 2022. So if you want to take a look to it, I'll put the link in the description. Now, moving into the monitor and operate phase, we're going to be answering the question, how can platform engineering help detect and remediate undetected or new vulnerabilities within production environments? So that we're in the monitor and operate phase. And for things like secure cloud configuration and secure development, it can get into a little bit of a gray area with your security operations team. However, there are a few things that platform engineering can still help. One of the examples that we went through is a library which a vulnerability was detected and it had to be updated. That's urllib 1.23. But that's just one outdated dependency within one repository. You usually have multiple dependencies within the same repository, and you also have multiple repositories that you have to maintain. So this can get really messy really quick. For that, the best solution is just to have automated dependency management. One of the tools out there that does its job really well, it's Renovate. Renovate does a few things. One, it checks all the dependencies in your project. It automatically creates new pull requests for all the dependencies that were detected to be outdated. And there's also the option of automatically merging the pull request based on conditions. So for example, if the version that was detected to be outdated, there's a new version and there's only minor changes, so there's no breaking change, it can automatically pull the request based on the conditions and do the merge. Uh, just a little bit of how that will look like. So I have Renovate integrated in my project. It will these are all the pull requests within the project. So it will create a number of pull requests for the different dependencies. As an example, this is one of the pull requests. It's just highlighting that it goes from 29.05 to 29.1. So the only thing that the developer will have to do is just to merge the pull request pretty much. So last but not least, we can just simply have automated scans being executed against our code. In my case, I'm just highlighting SonarQube as one of the options. The way that I'm achieving this is by having actions within GitHub that run recurrently towards my repository. And it actually generates a pretty report that specifies what is the current state, how's the current state of the overall code, if it failed, compared with a quality gate. But what's important is that actually generates a notification that highlights if there's anything new within my repository, which this is something actionable and not just a long report. So as a quick recap, we went through the code phase where we learned about using ID extensions and pre-commit hooks for security purposes. We also went through the build and deploy phases where we added validation steps within the pipeline before it gets deployed. And we also went through monitor and operating on how to automate the maintenance of our code. So thank you so much for listening and for attending PlatformCon. I hope you have learned something new that you can apply.